Hi everyone, I'm Tianwei from Mila. This is a joint work with Ben Eysenbach, Salakhutdinov from Carnegie University. This work is on recurrent modifier can be a strong baseline for many POMDPs. The first question is why studying POMDPs, partially observable MDPs? The first reason I gave is they are realistic. POMDPs replace states with observations in MDPs. A big question for MDP is where do states come from? As long as there is error in sensors, we can only perceive noisy or partial version of the states, which we call observations. In general, our real and world life could be viewed as POMDPs instead of MDPs. POMDP has many applications in the real world. And the second reason to study POMDP is they are general. In this work, we provide a unified view of sub-areas in POMDPs, including meta-IO, robust IO, generalization in IO, and temporal assignment. POMDPs are general, which means the methods that can solve POMDPs can also solve each sub-area, but not vice versa. Next, we move on to solving POMDPs with reinforced learning IO, which includes inference and control, two parts. The inference is to estimate the underlying state distribution, and the control is to perform IO on the inference database. Model-based approach learn the inference control separately, while model-free approach jointly learn the implicit inference and control with a sequence model in IO, which is our focus. Recurrent modifier is such a kind of model-free approach, classic in R literature, revived in deep IO. Why recurrent modifier for POMDPs? First, it is very simple to understand and implement. In theory, we do not need explicit inference. We just need to make sure that policy has sufficient memory. A modern architecture for memory is recurrent nets. Therefore, we can simply replace the Markovian model with memory-based models such as LSTM and GRU. And here is our recurrent actor and critic architecture, where the actor and critic networks each have an RN inside. And the second reason to use recurrent modifier is it is impressive in theory because RNs are universal function approximators. However, many prior work show that recurrent modifier is poor in practice, so they suggest not using it. But in this work, we show that it can be powerful, and it is actually the third reason. In this paper, we show several key considerations when building the recurrent model-free IO, including whether sharing or separating the RNs for recurrent actor and critic, the agent input space, and on-policy or off-policy algorithm, and RN architecture and context length. We highlight the factor that is largely ignored in prior work and provide some recommended options. Since recurrent modifier is simple, it is widely used as baseline, but it's shown to have poor performance in most cases. So here we listed how the prior work considered these factors and highlight their choices that maybe lead to the poor performance in the red ovals. And also we can provide our considerations. Finally, we provide a large-scale empirical study on many POMDPs. In each sub-area of POMDPs, we compare the corresponding specialized or more complex method on a benchmark where they evaluated in their paper, including 6 benchmarks with 21 environments. Our implementation of recurrent policy is at least on par with, if not greatly outperforms them in 18 environments. Here we provide an example of a standard POMDP benchmark from VRM, which is a model-based policy approach in POMDP. And also we compare PPO or A2C GRU, a recurrent model-free on-policy approach. We show that our implementation of recurrent modifier is better than VRM and PPO GRU in 6 out of 8 environments. Here we have already open sourced our code in GitHub, which received a lot of stars. Welcome to use it as a baseline. And takeaway is where MDPs prevail in our research, POMDPs prevail in the real world life. Recurrent model-free IO, a simple approach to POMDP can be a strong baseline in many environments, contrary to common belief. And here we show that implementation matters in it. So consider using our code to incentivize future research on history-dependent policies and POMDPs. We acknowledge those people who have helped our project. Thank you for watching.